Thanks, man.
Hi. So let's jump right in. This is a bad regular expression. You might think that all regular expressions are bad regexes, and looking at this example, I can't really blame you. But this one in particular comes from a Stack Overflow answer. A Stack Overflow answer that's been revised for over 10 times. This is the best they could come up with. If you hadn't figured it out by now, this regex is trying to match a URL. They get it right most of the time, but they still have issues with others. And that's fine too. In a way, this regex is job security. Regex creates bugs, we're there to fix the bugs, this is job security. So, hi, my name is, and I'm one of these. I work for this company, being one of these for them. I'm also a big fan of these, which some people think are this, and other people think are this. I think I skipped a slide or two, but you guessed it. If you were here 3 years ago, you might have seen a lightning talk. This was a lightning talk. And if you look particularly closely, you can make out that the guy on stage is, in fact, me. I'm wearing the ultimate disguise, though. I've got different glasses than last year. Here's another picture of me during the same talk. And if you look past the perfect jawline, you can see that I'm panicking. A bit like right now, really. But back then, I was panicking because we only got 3 or 4 minutes, which is pretty average for a lightning talk, but it's definitely not enough to explain all of regular expressions, especially not in a quick 3-minute talk. Luckily, today, they had me back, and I've got a bit more time. But I want to be absolutely clear about my intentions here today, and that's not to show you all of regular expressions in a quick 30-minute talk, rather just show you some quick tips and help you to write regular expressions without losing your mind. Regex is over 25 years old. There's plenty of tutorials, articles, videos, etc. out there that will help you get started, and I would just suggest taking the afternoon off to just get started with the basics. The basics aren't honestly that bad. It's the more advanced stuff that gets tricky, but... So yeah, what are we here for today instead? Well, part of writing good regular expressions is knowing when to use regular expressions, and more importantly, when not to use regular expressions. Because let's be honest, if we can avoid them, let's avoid them. And then in the second part of this talk, I'll show you some practical tips, 6 practical tips to help you write better regular expressions. So before we jump right in, just quickly to gauge the room a bit, let's start with a quick round of mandatory audience participation. Don't worry, I'm not going to have you jump around or do yoga or something, but just like we've done before, quickly, by show of hands, how many people here have used regex before in their lives? Good, I think that's almost everyone. How many of you liked it? How many of you didn't like it? I think some of the same hands for liking regex and not liking regex, and that's really what this talk comes down to. So yeah, it looks like I skipped another slide. I think I keep pressing this button. But yeah, the fact is, I'm not here to force you to use anything. I'm not here to force you to use regular expressions. In fact, it's usually worth considering whether a regular expression is the right solution for a given problem. Let's start off by looking at 2 examples. So both of these JavaScript snippets are going to match a 4-letter name starting with a capital X. And in this case, the regex solution at the top is actually shorter. However, you might agree with the second solution, which is just vanilla JavaScript string functions, is a lot easier to read and understand at a quick glance. So that brings me to my first point. Not every problem requires regular expressions, but not all problems can be solved with basic string functions either. It's actually more of a careful balancing act between not only the performance and complexity of a possible solution, but also the readability and maintainability. So let's look at a couple more real-life examples of where you might not need regular expressions. For example, when validating an email address, you might be tempted to use this regular expression that's going to match an email address as defined in the RFC 822 specification exactly. However, you'll be RFCing me close at pull request faster than the average Web3 company goes out of business. By all means, go ahead and try to validate an email address or the format of an email address using regex. But I can guarantee you that at some point, someone's going to come along with an email address using just emojis for the top-level domain, and they're not going to be able to register. This is a big deal if you're one of those Web3 companies that's going out of business. So instead, if you want to be absolutely certain that an email address is valid and exists, well, just send an email to it. We're all used to confirmation mails. There's also the perfect HTML5 email input field for front-end validation. There are several language-specific features like filter var for PHP. And finally, there are plenty of packages at your disposal that may or may not use regex under the hood, but at least you don't need to maintain those. Someone else will deal with that. The same goes for password validation. It's pretty easy to write 4 regular expressions to match each of these 4 password policies, but you could probably even do it in 1 regular expression, really. But the fact remains the same. Passwords using password policies like this are still allowing for weak passwords like this. So instead of following a fixed set of rules, I would recommend another package. In this case, ZXCVBN. So they're going to use pattern matching under the hood, so regex, something they call conservative entropy calculation, whatever that means, and most importantly, a 30,000 word list of common English words, names, and passwords. We're going to be throwing that all together in a melting pot, together with the user's password you're trying to validate. And in less than 20 milliseconds, it's going to output the password's real password strength. And in this case, Hunter1 is a pretty bad password. So for validating password strengths, I would recommend ZXCVBN. This is available basically for every language and framework you'll ever want to use a password in. If you want to go the extra mile, or in this case, the extra API, there's also the Have I Been Pwned API that will validate your user's passwords against a database of 11 billion previously leaked passwords. And they do all this without actually ever seeing the password. They use encryption or hashing, but the point of the fact is it's perfectly safe to send your password there. So again, packages for both of these are available everywhere on the internet. Just Google, that's your job, not mine. The same goes for date validation. I don't really know what a good date is, but packages like Carbon for PHP and date functions for JavaScript sure do. And if you, just like my dates, don't want to commit to the package either, you can always fall back to the language-specific libraries like the datetime class for PHP and the date object for JavaScript. Probably my most controversial slide until now. Parsing HTML using regex, contrary to popular belief, is definitely possible. However, there's actually this great Stack Overflow answer that's pretty infamous that goes into detail why it might not be the best idea. It's something about recursive patterns and an evil being called Salgo that will consume both you and your code. So the TLDR really is just use an XML parser. But yeah, would I recommend it? No. Is it possible? Absolutely. In fact, a little framework called Laravel do use regex in their blade templating language to parse HTML components, and they get away with it. So, however, let's move on before Salgo actually consumes this slide. The thing is, this also usually gets stuck. I think there's like too many effects layered on there. There we go. I always have to force this slide to move on before the animations end. So, finally, what do most banks and countries have in common? Well, huge amounts of debt and cards with checksums in them. So that's right. Most national identification numbers and credit card numbers usually include an additional digit or 2 called a checksum. And these checksums allow the developers, so us, to calculate or apply some formula to the entire credit card formula or the entire credit cards and compare the outcome of that formula to the checksum. If both numbers match, we know that the number was entered correctly. If they don't, a mistake must have been made. If this sounds like something you don't want to be doing in regex, you'd be absolutely right. I know there's been some cool articles on Hacker News about matching, I think it was matching correct formulas using regular expressions for sums and divisions, which is pretty cool, but this is not something you want to be doing in your application code. Again, even calculating the checksums is probably something you want to use another package for. So, no regex then. Does anyone actually know this fine? I was really concerned about that. It's from Vine, no? Just me? Okay, some of these jokes are for me, that's fine. Well, dust settles and everything's said and done. It should be noted that regex is still an incredibly powerful tool. Not only is it language agnostic, which means you can use it anywhere, anywhere that runs Doom. It's also an incredibly powerful tool, not only for using in programming, but also to help you program as a tool. Like it's a tool to help you program. Command line tools like rep, SED, AWK all understand some dialect of regex, and they can be used to parse config files, modify CSV on the fly, update config files, all from the command line or automated using scripts. Additionally, most editors like VS Code and the JetBrains IDEs all support some kind of regex in their find and replace functionality. And that doesn't just let you find a regex match and replace it with a fixed string, but it also lets you find a regex match, take some of these substrings or like some of the capture groups from the regular expression and use those substrings in the replacement string. I know that sounds confusing, but let me show you an example of one of these refactors I like to run quite often. So this is VS Code, but the doc blocks here are generated by PHP Storm. They're quite good at that too. These doc blocks document the return type of the functions below. However, they're 3-line doc blocks, while it's perfectly possible to have a 1-line doc block, which I prefer. So we can use regex and find and replace to fix this. Now, without going into too much detail, the pattern at the top right there is going to look for the comment open and close syntax and match everything in between. We can then replace the entire comment with the replacement string there, which is a single-line doc block with the original comment's contents put in there using $1 syntax. It goes a bit quick, but the result is there. We've refactored 3-line doc block comments to 1-line doc block comments using regex and find and replace. And these kind of refactors I also use quite often for changing namespaces, using global find and replace or even file names. You get away with it to use it in CSS or HTML. It's quite useful once you get the hang of it. So we've looked at some use cases where regex is useful, some use cases where you might not want to use regex. It really comes down to the age-old saying, if all you have is a hammer, every problem starts to look like a nail. But if all you have is regex, every solution is already screwed. So think of the next developer that's going to be looking at the code you're writing right now, and that might as well be you. And try to choose the right tool for the job, not necessarily the cool one or the one you're learning about right now. Because remember, even Tor uses an X sometimes. So that brings us to the halfway point of the talk. So now that the theory is behind us, we can look at those 6 practical tips I promised you earlier. Because the difference between theory and practice is often greater in practice than in theory. And in practice, it's pretty damn hard to write a regular expression that's readable and clean. So for tip number 1, let's start off by looking at what's actually wrong with regex. And then maybe we can look at some ways on how to improve on that. So the complete lack of white space, comprehensible words, and structure comes to mind. And on top of that, like all code, it tends to grow with features and edge cases. And before you know it, your pattern is on to multiple lines. So I did a quick Google search earlier about articles on writing clean code, and this is literally the wrong slide. This is literally the first article that I came up with. So according to that article, the regex at the bottom there is complete and utter garbage. There are no comments. Not only is there no indentation, there's no white space at all, let alone meaningful names or a reasonable line length. But here's the T. We can fix most of that by adding just one extra character, and that's the X flag. Now, the X flag is going to enable extended mode. And in extended mode, the underlying regex engine will ignore new lines, white spaces, and hashtags. So in the same garbage pattern from before, you can see we've now enabled the extended mode using the X flag. And this allows us to utilize these now ignored new lines and white spaces to properly format our code. And we can even use the hashtags to add comments like this. And hopefully you'll agree that this is already a lot more readable. This almost looks like regular JavaScript code that's indented. It's got some structure to it. It's got some documentation by comments. But let me remind you that this is just a normal, valid, regular expression. In fact, this works out of the box for PHP and many other languages, the exception being JavaScript. So for JavaScript, you can do some interesting things using string concatenation or tag templates is what they're called. But really, you just want to be using another package to keep your life easy. I recommend this one. I'm not going to try to pronounce the name. I can hardly pronounce regexes 20 times in this talk. But it really comes down to this package is sort of a polyfill for missing features in regex or missing features of regex between browsers. The important part being they support extended mode. So that was tip number 1, using extended mode for comments and white space. For tip number 2, we're going back to the basics. So one of the first things you'll probably learn about in regular expressions are the variable delimiters. So the delimiters are the forward slashes surrounding the pattern here. They're the boundaries of your pattern, so to speak. And most developers tend to use forward slashes for this, but they can actually be any of these characters, including the bracket pairs. Now, the cool part is every occurrence of this pattern, every occurrence of the pattern delimiter in the pattern must be escaped with backslashes. Otherwise, the engine gets all confused about where the pattern starts or ends. So now in this case, we're no longer using the forward slashes as the pattern delimiter, so we no longer need to escape every occurrence of the delimiter. So we can just get rid of those backslashes, which greatly improves readability again, as our string is now literally the string we're trying to match. Skipped another slide there, no worries. I was going to say, again, this matches. This is variable delimiters work in PHP, many other languages, with the exception being JavaScript again, but you can get away with it using that package I mentioned earlier. So that was tip number 2, using variable delimiters to your advantage. On the topic of reducing unnecessary escape characters, that's also tip number 3. So let's look at meta characters. So in regex, there are only 12 meta characters, not counting mark, that need to be escaped. Okay, cool. So what does this mean? Well, in a practical example like this, where the line at the top is a regular expression and the line below is an example of something we're trying to match, well, you can see that we've got several characters escaped with a backslash. And this is something I see quite often when developers are just playing it safe with regular expressions. They tend to escape every odd-looking character, and the regex engine doesn't really care, but this is really just adding a lot of visual noise and overhead. So let's go over these characters one by one, starting with the $sign. Well, the $sign is one of our 12 meta characters, so this needs to be escaped. Otherwise, the engine thinks we're trying to match the end of a line. Moving right along, the dash symbol is not one of our 12 meta characters. In this context, it has no special meaning. So we can just get rid of this backslash to escape it no more. The same goes for the greater than symbol. Not one of our 12 meta characters, no special meaning, no need to escape it here. And this might seem like small changes, but as you know, many small changes added together make for a bigger change. And it's really just about reducing that visual noise to make it easier to quickly see and understand this pattern. So the next couple of tips we're going to be seeing are all going to be about different types of capture groups. So if you don't remember what a capture group is, because I don't know, maybe you had friends in college, we'll do a quick recap. So here's a very primitive terminal and a very primitive pattern. And as you can see, the entire, I really have to stop clicking this button. I think it might be, doesn't matter. As you can see in the first example, the 2 lines at the top there, the entire match is always automatically capture group 0 or subgroup 0 or output group 0, whatever you want to call it. Now, by adding a pair of parentheses, like shown in the second example, the 2 last lines, we can capture a part of the pattern. And this is adding our first capture group to the pattern. And as you can see, this is now going to put full stack Europe in output group 1 or subgroup 1 or output array key 1. Now, by adding another pair of parentheses, we can also capture the literal word hello. Because that comes earlier in the regular expression, it's now going to take the place of output group 1, and full stack Europe moves to group 2. You can see the sort of swap places there. Finally, it's not very useful to capture a literal word, but capture groups can also be used to add structure and Boolean logic to your pattern. So in this last example, you can see we're capturing either hi or hello for output group 1, and still full stack Europe for output group 2. However, sometimes you don't want to be capturing any output at all. Sometimes you just want to use a group to add some Boolean logic or maybe even structure. In the same way where you wouldn't pass unnecessary parameters to a function call, you don't really want to be adding unnecessary capture groups or output to a regular expression. In those cases, you can use non-capturing groups. So here's the exact same example from before. And maybe in your application, we're just trying to match or see the thing or the person we're greeting and not necessarily the greeting. So say, for example, we're only trying to match full stack Europe and not hi or hello. Well, in those cases, you can use this very similar syntax to add a non-capturing group. And this works exactly the same as before. It's still adding that Boolean logic, but it will never show up in the output array. So non-capturing groups keep your output clean and easy. The next type of capture group we'll be looking at are named capture groups. So if you looked at the previous examples as output arrays, they're not the best developer experience. Accessing matches by array index, especially in an unassociative array, is error-prone. And if the order of the capture groups changes, like we also saw earlier, you have to update the indexes. This is really just a mistake waiting to happen. As a solution, you can use named capture groups. Let's start with a fresh example that's going to match a day, month, and year in a date string. We know it's a date string because it's got it right at the bottom there, but we'll never know whether it's going to match a US date string or a normal date string. So until common sense prevails, we can use named capture groups to clear things up. And now using this syntax, we can actually name each of our capture groups. And this isn't just documenting our code without using those comments. We can still use them, we're still in extended mode, but we don't really have to. This is self-documenting. And this is also going to make it really easy to integrate this pattern into the surrounding JavaScript code. Let me show you how that works. So here's some JavaScript code, and you can see the same date matching pattern at the top there. It's just wrapped onto one line to make the entire slide fit. We're no longer using extended mode. But the important part is at the bottom there. The year named capture group we're logging to the console directly corresponds to the year named capture group from earlier. And I think that's a really nice integration. I would go as far as to say to always use named capture groups if you're trying to get output from a regular expression. In the same breath, it's worth mentioning or talking about the up-and-coming end flag. Now, the end flag will turn all unnamed capture groups to non-capturing groups by default. So in the first example there, that's a regular unnamed capture group, and that divider between key and value that we're capturing is never going to show up in the output. This is strictly adding that Boolean logic. If you want the divider to show up in the output, you'll have to be explicit about it and name it as shown in the second example. So the final type of sort of capture group are subroutine definitions. They are a lot like named capture groups, only this time we're going to define them once and then reuse them multiple times throughout our pattern. So you can see we've defined the same year, month, and day capture group from before, only this time as subroutines. And we can now utilize these subroutines to recreate our same date matching pattern from before, only this time it's super readable and fits onto one line. Now, doing this with a fixed date string is obviously not very helpful, but you can see this being pretty useful in an example like a date range. A date range that consists of a date string, a colon, and another date string. Well, in this case, it suddenly makes more sense to have the single date string as a subroutine, and then use that subroutine twice to create the full date range matching pattern. So, before I start wrapping things up, I quickly want to show you some tools I think are quite useful and might be useful to you as well. This slide was initially 10 times as long, but then most of the tools were included in the awesome regex page at the bottom there anyways, and I really just wanted to give a quick shout out to regex 101. An honorable mention goes to the JetBrains IDEs because they do support syntax highlighting for regular expressions and even this cool little inline pattern matching tool. But sometimes you just need the big guns. The big guns being regex 101. So this is basically a full-on IDE for regular expressions in your browser. They've got syntax highlighting, a debugger, unit testing, all built in. You can try your pattern onto multiple engines. They've got dark mode, which is important for developers. There's a text explanation of your pattern, a reference guide, an included library of community snippets. It's all there. My favorite feature of theirs is the step debugger. So you guessed it, the step debugger allows you to go through the pattern step by step and one of its matches to see at what point you might have messed up. If you messed up real bad, you might need the regex, which has the same step debugger, but it also includes this cute little graph diagram of every twist and turn that your pattern might take when trying to find a match. You might have heard about every regular expression being able to be represented by a finite state machine. Well, this is sort of the graph representation of that state machine. Before I ramble on about state machines, if you're somehow still interested in learning regular expressions after seeing this talk, I've got a couple of resources here for you as well. The first two being a shorter and a longer article. If you're a lazy learner like me, there are some interactive tutorials. And finally, if you're the kind of person that enjoys psychological torture, you can use or check out regex crossword puzzles. So next time you're met with a problem that requires regular expressions, maybe consider not using them at all. If you have to, you can use extended mode for comments and white spaces. Try to avoid unnecessary escaping every character by remembering those 12 meta characters and choosing the appropriate delimiters. Also, name your capture groups to further document and integrate with surrounding code. Or use non-capturing groups if you're not trying to capture any output at all. And finally, if you're going really down the rabbit hole, you can use subroutine definitions for cleaning up those longer regexes. Oh, most important of all, never use regex to parse HTML. That's illegal, and Zalgo will find and kill you. Thank you.